if we need to solve this, okay, for each of these inequalities, okay, we need to first we treat each of them as an equation, and then we graph them out. So let's start with the first one, okay? First of all, we want to treat it as an equation. So let's make it y equals to 2. Graph y equals to 2. And obviously, it looks like this. But because this is just greater, okay, we have to make this as a dotted line. If it is greater than or equals to, then we make it a solid line. Okay, so here's the first step. And remember to label the line, okay? So this should be a y equals to 2, okay? We are referring to this inequality, y greater than 2, okay? So this line actually divides the universe into two parts, this part and this part. But if we just want all the points with y greater than 2, which half do we want? Okay, the easiest part is we just need to substitute some points just to do checking. Usually we substitute 0, 0 into the equation and see if it works. Okay, but this one is much easier. It says y greater than 2. That means all these points, okay, for example, this one, the y coordinate is obviously greater than 2. So is every single other point in the same region. And if one point on a region works, the entire region will work. And the other side will be the opposite that we don't want. For in this case, y greater than 2 is just this half of the universe. So we want this part. And so I put a little arrow to indicate the region that we wanted. So now we're done with the first one. Then let's move on to this one, a little more complicated. So step 1, we are going to plot this equation on a graph. Okay, what you need to do is just you make up some numbers for your x, and then you just put it into the equation, and you get the corresponding y's. So in this case, it will be this point, and this point. To graph a straight line, okay, actually 2 points are good enough, okay, but to graph these things, okay, I would suggest using 3 points because it would be more accurate. And also, if you use 3 points, and if one of the points are not on track, then you know you have made a mistake. But you cannot check that on 2 points, right? So 3 would be better. And if you insist to do 2 points, maybe you could also use the x-intercept and y-intercept, because one of these numbers would be 0, and it's very quick for you to calculate the numbers. Now again, because it's not greater than or equal to, then I will make this a dotted line. And here's the label for the line, not the inequality, remember. Step 2, I want to subpoint to select which region that we're choosing in this inequality. Almost all the time, unless the origin lies on the line. Otherwise, it's almost the perfect point for you to check. So when x equals to 0, y equals to 0, I've put it into the inequality, not equation, inequality. So left-hand side equals 0. And is it greater than RHS, -3? Yes, it is. And so the inequality holds for 0, 0, right? And because 0, 0 represents this part of the world, okay, so this part of the world is what we wanted, and we reject this part of the world. So we'll put the little arrow to indicate the direction, okay? Now let's move on to this one, okay? We are going to graph x plus 3y equals to 9. And because this time it's less than or equals to, okay, then we are going to put a solid line. Step 2, again, we choose 0, 0. This part is what we wanted. And by the way, if it doesn't work, then the opposite side is what we wanted, okay? So again, origin 0, 0 is less than 9, so we wanted this part of the world. Now we're done with all 3 lines. We're going to combine these regions all together. So for this line, we want it upward. And for this line, we wanted this part. And for this line, we wanted this part. We are going to find the overlap area, region, that is exactly this triangle, okay? So then you will highlight this region and you will answer this shaded region and figure actually are the solutions to this inequalities. Now, what's the meaning of this? The meaning means every single set of coordinates, they will satisfy all of these three inequalities. For example, let's say this one. This is negative 0.2 and positive 2.2. Okay, and if you put in every single inequalities here, okay, it still works. But except the ones right on the dotted lines, those are not included. But the ones on the solid lines, those are also part of the solutions. So here's the summary for part A. You do 1 and 2 for each of these three, and then you look for the overlap and you highlight it, and that would be step 3. Now part B. Which of these solutions in part A have integral values for x, y? In this case, we can disregard all these, and we only have these 3 points. These 3 points to think about. However, none of these 3 satisfies all 3 at the same time because they lies right on one or more of the dotted lines. Points lying on the dotted lines are not solutions. Okay, so there's no solution.